things will become more easier when we jump into ICAP, JCAP, KCAP. Today's lecture is actually based on ICAP, JCAP, KCAP. Okay, so how the usage of ICAP, JCAP, KCAP is going to improvise our problem solving and make sure that no mistakes occur. And automatically, if we follow a particular way of solving, automatically we will feel comfortable and we will get the right answer. That was my focus for this lecture. Now, magnitude you find out just like that.
Magnitude.
Sorry, what?
Finding magnitude is.
Direction. You
Yes,
just
sir.
have to look in the figure if they are like charges, unlike charges, or not. So positive charge,
Where the like charges are fine.
negative charge, positive charge, negative charge, or negative charge, positive charge. Actually, these two are basically same. If we look this from a reverse
Yes.
direction, we will see, look at this. But I drew all the four possibilities that can occur. So now direction is what you are mainly bothered with. Direction, if I draw the arrows from the charges, and those arrows are representing the direction of force on this that particular charge. The direction of force on this particular charge will be left to right.
Yes.
Direction of force on this particular charge will be right to left. Similarly, direction of force over here, what should it be?
Same as the above.
Because like charges repel each
Yes.
other. So, and here, unlike charges attract each other.
Yes, sir.
So all the arrows that we are showing is basically representing the direction of the force that is acting on that particular charge. Is this clear?
Yes, sir.
Oh, simple. If you have either of this, you like charges repel each other, you already remember it. And here you know, unlike charges attract each other, right?
Yes, sir.
Take it down. So whenever you get any kind of a confusion, look at this figure and try to figure it out. In between two charges, what is exactly happening and how will you draw the line? And like I said, choose a particular direction as positive ICAP. So just to avoid confusion, I am keeping left to right as positive ICAP because we take left to right as positive ICAP in all our chapters, right?
Yes, sir. Sir, could you, I mean,
I am taking the coordinates x-axis and y-axis.
yes, sir.
And let the units along x-axis or y-axis be measured in terms of kilometers.
Yes, sir.
So first I will take easy situation, then slowly I will increase. So remember the units along x-axis, y-axis are kilometers for all the questions.
Mhm.
Now two charges are placed at P and Q. Let the point of P be 20, 0 and let the point of Q be 60, 0. Okay.
Yes, sir.
The charge at point P is 30 microcoulomb and the charge at point Q is 100 microcoulomb. Now Obviously, when I give x-axis, y-axis, I'm assuming that you will find it out in terms of I cap and j cap in general.
Yes, sir.
So find the electric field, find the force on P due to Q. Okay. First magnitude is 9 into 10 power 9 into
30 into 10 power minus 6.
100
We
into
have
10.
to take in care, sir.
Distance between them is 40 kilometers.
Yes, sir.
40 into 10 power 3 square. So I'll have 9 threes are 27.
It is
270.
1.6 into 10 to the power 4.
I think it is correct.
Yes, sir.
10 power 9, 10 power 3, 10 power 5, 10 power minus 1, and 10 power minus 7.
Mm.
9 into 30 is 270.
Yes, sir.
40 square is 1600. Okay.
Mm.
10 power 9, 10 power 3, 5, minus 1, minus 6, which is minus 7. So you can find the magnitude. How much are we getting over here?
27 by 16 is 1.6.
1.6, is it?
Yes, sir.
Okay, so I'm taking 1.6 into 10 power minus 8
Minus
newtons.
1. Yeah.
Minus 8 newtons. Now, of course, we want direction part. We want the
Yes, sir.
force on P. These two are like charges. So first, we will draw up the directions of both.
Yes,
Because
sir.
we want on P, it is minus I cap. Clear?
It's that the left side vector and the right side vector gets cancelled.
No.
Continue.
See, we're not adding these vectors. We need to be very sure about what these vectors mean. This vector is basically representing force vector on P due to Q, right? Whereas
Yes,
this
sir.
vector is representing force vector on Q due to P.
Mm.
Forces are acting on different objects. So your brother comes to your room and pushes you. My mother comes to my room and pushes me. Will we add these two forces? No,
No, sir.
because I will add forces when two people come and push me.
Mm.
Then I'll add forces for that particular situation. Is this clear?
Yes, sir.
Done?
Sir, that's why I was not getting correct for the unlike charges.
Yeah, I know. That's why I told you yesterday, right? There'll be difficulty, but we got it clarified. And whenever you get a doubt in that, you will look at those four things that we've drawn so that you will be comfortable again. Okay, now I'll change the values and also the position. Again, both x-axis y-axis are in kilometers. Okay, I have one charge on A, one charge at a point A, which is located on negative y-axis, and the other charge located at point B, which is on the positive y-axis. Okay.
Yes, sir.
Now, uh, Like I said, it's already given units are kilometers. So I'm only going to give the coordinates of it. So this is 0 comma 40, and this is 0 comma 60. Okay.
Yes, sir.
The charge at point A, we will take it as 10 microcoulomb. I'm making the calculation easier. And the charge at point B, I'm taking it as 100 microcoulomb. Okay. We need to find force on B. Find force on B due to A. Solve everything and tell me the answer in terms of J cap minus J cap.
Yes, sir.
This is seventh question, is it?
Yes, sir.
The magnitude of force is basically, see, first of all, we'll draw these diagrams, arrows, and we already know that the force on B is in the upward direction, so it is plus J cap. So the answer will be positive, right?
Yes, sir.
Now let us check the magnitude also. So 9 into 10 power 9 into 10 into 10 power minus 6 into 100 into 10 power minus 6 divided by, what is the distance between them? 100 kilometers.
100 into 10 power minus 3 whole square.
10 power plus 3 whole square kilometers.
You gave it in.
Kilo is 10 power 3. So,
Sir, yes, sir.
so I gave everything in terms of tens, so we don't have to do anything about it. It's just 9 only. Now we just have to do this. This is 10 power 9, 10 power 10, 10 power 4, 10 power 6, 1. Numerator is completely gone.
Yes, sir.
Or you can say 9, 10, 12. 6, 6 is minus 12. So whatever is there in the denominator we have 10 power 5 whole square, which is 10 power 10 comes up. So basically it is 9 into 10 power minus 10 Newton J cap in the positive direction.
Yes, sir.
Okay.
Hmm.
Let us solve one more. So eighth question. I'll keep A and B just the same. I'll just change the coordinates of it because I want you to simply solve and make sure that you get the right answer. I'm changing the coordinates and also the value of the charge. Question will still remain the same. Find the force on B due to A. Okay,
Yes, sir.
fine. So take the coordinates of A as 0 comma minus 30 and coordinates of B is 0 comma plus 60. Okay, I haven't given charge. I need to give charges.
Hmm.
This is 2 microcoulomb and this is minus 6 microcoulomb. A
Yes,
charge at
sir.
A is positive, charge at B is negative. Find force on B due to A. First, let me draw the directions. So, because we have unlike charges, they will attract each other. So, on B, the arrow will be downward. On A, the arrow will be upward.
Yes, sir.
So, the idea is we know that the answer should be minus j cap, right?
Yes, sir.
Now let us find the magnitude. So F is equal to K 9 into 10 power 9 into 6 into 10 power minus 6. See, remember, once I figured out what the direction is, I don't have to bother about positive negative substitutions in magnitude.
Yes, sir.
Make sure that this is clarified, or else sometimes what happens is while substituting you will see the charge is negative, you will substitute negative, negative into negative, you'll write it as positive.
Mm.
So what are we doing? So this is what we do in vectors in every chapter actually. We try to understand the significance of the direction individually and try to understand the magnitude of that particular.
But I found it putting it, I mean, I didn't do it from the figure.
Might get confusion in future. So remember, is all I'm saying.
Yes, sir.
If you're already comfortable and you're getting the right answers, it's great.
Sir, can you tell how did you find?
Unlike charges, arrows should be towards each other, right?
Yes, sir.
Because attraction.
Yes, sir.
Wherever I'll draw,
Mm.
if it's attraction, I'll have to draw it together towards each other.
Yes, sir.
If it is repelling, then I'll have to draw it away from each other.
Yes,
So
sir.
once I drew these two arrows, question is asked on B. So I just look at over here. The direction is downward, which is minus j cap.
Okay, sir.
So I know the direction is minus j cap. Now I only have to get magnitude of it, not bothering about the positive or negative sign of the charges anymore.
Yes, sir.
Okay. Now, so this is 6 into 10 power minus 6 and this is 2 into 10 power minus 6 divided by, what is the distance between them?
Sir, 90 into 10 power 3 whole square.
90 into 10 power 3 whole square. So I think you can do this, right?
Yes, sir.
I think it's the value that we'll get is something like 4 by 3 and remaining is all 10 power kind of a thing. 4 by 3. So here we have 9. 9 minus 6 is
By 3.
3. One second. 3 minus 6 is minus 3. Now from here minus 11. 4 by 3 into 10 power minus 11 I am getting.
Isn't it 2 by 3?
Uh,
It
2
is 4 by
into 2.
Yes, sir.
Okay, so the force vector, I will write it as minus j cap. That means this will be minus j cap. You can use newtons. Is it clear?
Yes, sir.
Now I want you to write the side heading as finding unit vectors. That means now we are not going to do electrostatics. Now we are first going to focus on finding unit vector. Finding unit vector. Till now we had I cap, j cap straightforward. But suppose if it's not parallel to x-axis or y-axis or anti-parallel to either of them, then what? So for that, first I need to understand how to find the unit vector. Once I find the unit vector, then I can go into the solving just like I was doing previously. Okay.
Yes, sir.
So did you write this highlighting finding unit vector?
Yes, sir.
So I'm not writing any numbers anymore of question because this is vectors that we're doing. So let us choose, so we'll draw a big Cartesian and choose multiple points. I'm not choosing origin because 0, 0 has now become very trivial to you since last 1 year, right?
Yes, sir.
That's why I'll choose some random 2 points. Let us say we'll choose 2, 10, 2, 10, as some point A, choose some point B as let's say 8 comma 15. Okay,
Yes, sir.
now first let me do the unit vector of AB cap. Okay,
Yes, sir. It is x2 minus x1 whole square.
right. So I'll start off like this. I will first, because we are in the initial stage right now, I'll write the entire detail of it. Slowly I'll start to write, like you said, straight directly substitution. So the unit vector AB can be written as the vector AB bar divided by the magnitude of it.
Yes, sir.
This by definition of unit vector we know it. Now, how do I write vector AB bar? Remember, it is xb minus xa I cap plus yb minus ya j cap.
Yes, sir.
Whatever is here, second one, you have to substitute first one from second one. Understand that? Okay. And in magnitude, we don't have to worry because it is anyways square root of x2 minus x1 whole square, right?
Yes, sir.
So in magnitude, not much of a botheration. Only in the numerator is the botheration. Okay, whole square.
Yes, sir.
So now we have to substitute b and a, right?
Yes, sir.
So what will I get numerator as? Tell me directly. Xb minus xa.
6 I cap
6
plus
I cap plus
5 j cap
5 j cap divided by,
under root 36 plus 20.
good, under root 36 plus 25 is how much?
60.
61.
Yes, sir.
Now idea is that I found AB cap. Okay.
Yes, sir.
So why am I doing this? Why I am doing this is because suppose in AB, at A there is a positive charge, at B there is a negative charge.
Hmm.
So now you know the directions, right? When unlike charges, you will direct it towards each other.
Yes, sir.
If this is AB cap, that is BA cap.
Yes, sir.
And in vectors, we already know BA cap is minus AB cap.
Yes, sir.
That means we already know the opposite unit vector also once we find one direction unit vector.
Yes, sir.
Is this clear?
Yes, sir.
So simply, uh, suppose we need to find force.
Hmm.
So what will I do? Suppose, for example, I am saying I am not solving literally. Force on B due to A.
But we basically need the magnitude only, right?
That's why I said I'm not literally solving it.
Yes, sir.
Force on B due to A. So first I will write the magnitude. First I will write the
Minus
magnitude.
AB
So let this.
cap. Yes.
What I mean to say is, in the direction part, I'll just substitute minus AB cap.
Yes, sir.
Understood? This is AB cap minus AB cap. Simple. Is this
Yes,
clear?
sir.
Now, let me take a point C and we'll take the coordinates of it as 6 comma 6. Okay. Now, first I want you to find what is AC cap.
Yes, sir.
Okay. First I want you to find what is AC cap.
4 I cap
No.
minus 4 j cap.
Slowly. I am not that fast. Next, I want you to find BC cap. Okay.
Yes, sir.
Then I am saying that the charge at point C, B, positive charge.
Yes,
Okay.
sir.
You just have to first find AB cap, BC cap, note it down. And you just have to write just like I've written over here. So here subscript we can keep AB because magnitudes AB, BC, CA will change, right?
Yes, sir.
So I want you to write what is the force on C due to A, and the next thing, force due to or force on B due to C. So I am already writing. We are not bothered about this magnitude part. Here we'll get AC. You can write AC or CA, that's our wish because it is just magnitude. And here we'll get it as BC, right?
Yes, sir.
Now I just want you to find these unit vectors and then tell me what you're going to substitute in terms of direction after this.